welcome back to the Glacial Gold Hunter. As you can see, we're at Lake Superior today.
Wait, you expect me to believe that?
Kind of. So back when I was gold panning on the shore, I was also collecting samples of quartz. Now, I've done this experiment before by grinding up pieces of quartz from Wisconsin creeks. But this time, I'm doing it from a different area. These are from gold-bearing spots on Lake Superior. So I want to see if there's any gold locked up in the quartz here. Now, if I look at a lot of these pieces, they look completely barren. Pure white quartz. I don't see any sign of mineralization. And honestly, I don't have a lot of hopes that there is any gold in there. But I'm going to crush them up just to see for sure. However, there are some samples in here that do look a little bit promising. Now, most of the gold that we find comes from the glaciers, and the source would be a lot of the greenstone and orogenic deposits in Canada, in Ontario for us. Orogenic is a geologic word for mountain building. So long ago when mountains were building in Minnesota and Ontario, gold was also being deposited. And here's an example of one of those gold veins. Now, you can see on both sides of this vein are granite, and in between is this piece of quartz. Right there, something's in that quartz. That might be something interesting, but we'll find out when we crush it up and pan it. Now, this is an example of some schist, and you can see this vein structure, but if you look closely in the vein, you'll also see these dark bands. Now, that reminds me an awful lot of what I found in the underground gold mine in Nevada. Now, these veins of silver ore contained gold, and that's what Newmont was after. I don't know what these veins here are, but it's possible that that's some kind of metallic mineralization. Maybe there's some gold in there. Again, we'll find out when we crush it. Now, the most promising piece that I have is this discolored one here. And you can see there's these big nodules of oxidized zones. That's where pyrite was. You can tell that the pyrite is being weathered out because there's that hole there and it's very stained with rust. That's a telltale sign that sulfides were there. And this is all metamorphic rock on the outside. Now, this isn't pure quartz. You can see there's a lot of quartz right there. You can see how glassy that looks. But then you look at these minerals here and you can see cleavage planes. See that glint right there? That's the surface of a cleavage plane. Quartz doesn't have cleavage planes. That's going to be the cleavage plane of a feldspar, potassium feldspar. So this would be a pegmatite rather than a pure quartz vein. A pegmatite is a mixture of quartz and feldspar, but there can still be gold in a pegmatite. So we're going to crush that up. But before I crush any of these up, I want to make sure they're washed clean so no free gold is sticking to it. I want to make sure that the gold we find is found from the inside of these rocks, not the outside. So let's wash them. Now, these are already washed by the waves and they're pretty rounded, so I don't think there's going to be any gold stuck to them. So this will be a quick, easy process. So there's a little sand at the bottom of that box. Let's see if any gold came with that black sand. And there's one speck right there. He tried to get away, but we got him. Alright, they're all cleaned. Let's get to crushing them. Now, the first thing I'm going to do is roast and quench my quartz so it's easier to break up. I'm going to put it in one of my furnaces. I've got a number of these to pick from, but for some reason you guys tend to like this one. Here's that one piece of quartz I was looking at earlier. Look how red it got now. Firing it made it crack. Probably break it by hand, yep. See, there's more schist in that one than I thought. It's definitely a mixture of quartz and feldspar, and even some other stuff in there. I'm not trying to melt this, I just want to get it red hot. I melted it, it's going to be a big blob of glass. I don't want the water to splash in my crucible, so I'm going to try to dump it in here. Now, since this is the most promising looking piece, I'm going to crush this up separate and pan it out separate. Just because I want to see if the look of it really matters. Just to kind of test my idea. But just because there's sulfides in here does not mean there's gold. There's sulfides everywhere. They're kind of ubiquitous. But in a place where there's a vein structure forming and sulfides, that can be a good indicator mineral of gold. And the reason is because gold does not like to be in solution, but sulfur helps gold go into solution. Deep inside the earth where the temperatures and pressures are allowing these fluids to collect these ions, sulfur helps the gold go into that fluid. Once it travels to the earth and hits a point where the pressures and temperatures are right for the precipitation of those minerals, as the sulfur is coming out of solution and precipitating itself, then the gold is left behind. And like I said, it doesn't want to be in solution. So as the sulfur leaves, the gold is left alone, and it's like, well, I'm going to solidify too. So at a point where you see the sulfur forming, you can also have gold forming. In chemistry, it's what they call a ligand. Sulfur is a ligand. Not a chemist, I can't explain it very well, but basically it's an element that holds the hand of another element. So the sulfur is holding the hand of the gold, and when the sulfur precipitates out, it lets go, so the gold precipitates as well. So this could be an indicator that gold was precipitating as the sulfur was forming. Now sometimes the gold is so small that you can't pan it. You have to chemically extract it out of the sulfur. But maybe there's something to see here. So we're going to do this separate. So we're going to pull out our handy dandy rock crusher. Remember, quartz dust is really carcinogenic to the lungs, so we're going to wear a mask so we don't get mesothelioma.
If you or a loved one was diagnosed with mesothelioma, you may be entitled to financial compensation.
Loud noises!
I can't get it super fine in one shot, so take a couple shots at it. See, that's all nice, panable material. That's a little too coarse, so I'll crush that again. Alright, that's crushed down. We'll set that aside. Now we'll crush up our quartz pebbles here. You can see some of them look like they're even whiter than when I put them in the roaster. Some of them had some minerals in there that obviously are not quartz that darkened up too. So we have a variety of different quartz-bearing stones here. Most of them did not show any sign of oxidation, so I don't think there's any sulfur in there, sulfides. But you can have gold without sulfides too. Geology is very complicated. So we need to test, and we'll see if there's any gold in here. Some stones show that there is more than quartz though, and I think that's promising. You can see once it's fractured, there's definitely more than just quartz, but I don't see any visible gold. Yet. There's round one, let's do round two. Now for crushing the bigger pieces, this thing really works great. When it gets to this rock salt size, it really doesn't do a very good job because it builds up and the one piece protects the others. It's like a snowshoe for the rocks. Now, I can't remember who it was, but I saw one guy who simply had a plate of metal and then he had a metal ring that he would put over it. And then he'd take a regular hammer and he'd crush the rocks up that way. But he could move the ring around so it could like float over the spots and he could actually hit the grains that need to be broken. I got a small plate of metal and a roll of duct tape. I think I can do the same effect. That really worked well. I wish I remembered where I saw that idea, but it was a good one. Now this duct tape method does work pretty well, but it's still kind of slow. I've got a little pile left to do, but I have a pretty good representative sample right here. So I think I'm just going to pan this out, and if I see anything, I'll come back and do more, but this will tell us what we need to know for now.
I used to be an adventurer like you, and I took an arrow in the knee.
Alright, which one should I start with? I'm going to save the oxidized one for last. So we got all that white quartz right here. We'll pan this first. You just never know what you're going to find. There's a little something in there. Let's try to consolidate all that. So that's what we got. And I think most of that is sulfides, but I think there are a few really tiny specks of gold in there. It's so small and so minute that I'm not sure I could really tell for sure, but it looks like there is some gold. Really tiny, tiny gold. But now let's pan out this oxidized one. There's going to be a lot of mica in this one because it was in that schist. And mica is one of those minerals that can be all sparkly. It can fool some people, but it looks different than gold. That's everything out of the white quartz. Just a trace amount. Hardly anything. And that's everything out of the oxidized quartz. Hardly anything. Just a trace. But there's a few specks of gold even in that. And those pieces of gold are so tiny. So tiny you can barely see them. So I think we can definitively say yes, there is some gold, but it's so tiny. It's the smallest gold I've ever seen, but it's there. I got more out of the white quartz than the oxidized quartz, but I had more material there. There's still a tiny trace of gold in that oxidized quartz too. Not too profitable in terms of gold, but profitable in terms of knowledge. That's a fun experiment. I like learning new things. Thanks for coming along. Come on back for the next one. Bye-bye.